in order for us to be able to communicate in math, we need to be able to have a common vocabulary. So what we're going to do today is we're going to talk about some very common expressions that we use in math class so that we can communicate effectively and make sure we understand what each other's saying. So let's just start off quickly with an algebraic expression. An algebraic expression contains variables, constants, and operations. So let's go ahead and write that down. Contains variables, constants, and operations. So something that would be an algebraic expression would be something like x plus 3. I have a variable x, I have an operation addition, and I have a constant 3. We need any part of this can contain a variable, any part of this can contain a constant. There'll be more parts we'll talk about later, but one example would be x plus 3. Another algebraic expression would be something like y divided by 2. A non-example of an algebraic expression is when we don't have any algebra parts, when we no longer have any variable involved. So an expression such as 3 plus 1 is no longer an algebraic expression, it is just a numeric expression. A variable, I already used the word a variable, is just a letter or symbol used to represent a value that can change. Sometimes you also hear it just being called a letter or a symbol used to represent an unknown. An example would be the letter X. We use that a lot of times in algebra. The letter Y. And if you think back to when you were a lot younger, there's times when you would be doing problems where you'd like fill in a box to finish up an expression or an equation, excuse me. That box is actually starting to get you to think about variables. That box is representing an unknown value, something that might change. A non-example would be a number, such as 3 or negative 2. Continuing on down, a term is a part of an expression. And these parts are broken up by addition and subtraction. So these are parts of an expression to be added or subtracted. Again, like I said earlier, these terms are split up by these plus and minus signs. So, for example, if we have an algebraic expression such as 5x plus 2, I really have two different parts. I have this first part right here, that first term, 5x. I have this second term right here, 2. So, instead of looking at these parts, if we were looking at this whole big thing, this whole grouping, that is no longer a term, that is two terms. Two different parts. A factor is a quantity, if I could spell quantity, that is being multiplied. So, for example, if I have 3 times 2, this is a factor, this is a factor. The end result, which we obviously know is 6, is called the product. We'll talk about that in a second. Another way we will see factors, especially with algebraic expressions, is if I have 3x, that actually means I have a factor of 3 and a factor of x, I'm really multiplying the two together. So, instead of having a factor, we might have a different operation going on, such as 3 plus 1. That is, neither one of those are factors. Those are two different terms that are being added together or summed together. Moving on down. I'm going to pause it because I need erasing. Like I said earlier, the product is a result of multiplying those two factors together. So let's go ahead and write that down. The product is the result of multiplying two numbers together. Wow, math teacher spelling two wrong. So, for example, we said if we have 5 times 3, I have a factor of 5, a factor of 3. My product, my end result, is actually 15. And this number right here is a product, the end result. So a non-example, again, would be if we were doing something besides multiplying. 3 plus 1. The operation that's happening there is addition, so this is no longer a product, even though I know that the answer is 4. That is not a product. Power. Power expression is really just something that has a little number above it, an exponent. A lot of times you'll hear people say power, and that's actually representing whatever the exponent is. So, we're going to say that power is the number of times you multiply a number by itself. So, for example, if I have 2 squared, the power on this is 2. It's called an exponent. We're going to talk about that next really quickly. But this little guy right here is a power as well as an exponent. We would say 2 squared or 2 to the second power. So this guy right here is power, which means that thing below it, right here, that does not have anything to do with the power of the exponent. That's called something else. It's called the base. We'll talk about that in a second as well. It's something completely different. So, like I said earlier, power, exponent pretty much mean the same thing. This is just another way of saying power. So again, an example would be, let's say instead if we have 3 to the 5th, it says 3 to the 5th power. That 5 is really telling me how many times I'm going to multiply this base by itself. So just like I had up here, I had 2 squared. 2 squared really means 2 times 2. I'm multiplying it by itself 2 times because that's what the power is. And we all know 2 times 2 is 4. 3 to the 5th power really means 3, the base of 3, times 3, times 3, times 3, times 3. Well, that's a little bit harder to do in your head, but I like doing this by taking little parts. It makes my life a little bit easier. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So I'm really just looking at the problem 81 times 3. 81 times 3, well, 8 times 3 is 24. That 8 is really represented in 80. So I have 240 and another 3, 243. Again, a non-example would be the base down here. Speaking of base, let's scroll down a little bit and take a look at base. Again, the base is the bottom part. So like the expression we had earlier, we had 2 squared. This number right here is the base. So I'm just going to say the base is a number that has an exponent on it, or power, aka as a power. Good, so all we're going to do is we're going to take what we just learned and we're going to actually talk about how we would communicate some of this stuff to each other. So if we wanted to actually communicate, and we have this expression right here, this right there. There's a lot of different ways we can say this. We'll always have some sort of combination of math lingo as well as really expanded lingo. I would say this by saying 3x to the 4th power. That would be how I would say this. I would say 3x to the 4th power. Now again, if I wanted to, I can get really, really, really in-depth detail with this. I could say the product of 3 and an unknown number to the fourth power. Again, there's a lot of different ways you could write this as long as we can make sure we're communicating it. So if we take a look at this next one, I want you to think of one way you might be able to actually communicate this next algebraic expression to someone. Again, there are multiple correct answers. And sometimes we are more detailed than others. If I were to actually enunciate this and say this to someone, I would say 5z squared plus 16. Now again, if you wanted to, you can get into a lot of detail and actually expand that. You could say the product of 5 and an unknown squared plus 16. And there's a lot of different ways you can go about doing this. Just like I said earlier, there's a lot of different ways we communicate. Our four main operations are addition, subtraction, multiplication, division. There are a lot of different words we can use to communicate that we are using that operation. So what I want you to do right now is I want you to pause this video and I want you to think about different ways that we can express that verbally and with different words, how to add, subtract, multiply, divide. Because those are the words we probably used to, but we can hear them other ways as well. So pause it and think about it. Here are some of the most common ways you would probably hear these operations communicated. Addition might be plus, sum, increased by. Subtraction might be minus, difference, less than. Multiplication might be times, product, equal groups of, or even just the word of. Division would be divided by, and the one you're probably not used to hearing is quotient. There are many other ways you might be able to explain, or you might be able to communicate that you are using addition, subtraction, multiplication, division, but these are the most common ways. So let's take a look down a hair further. With what we just learned, we can actually take what we just learned and we can actually take words and turn them into algebraic expressions. A number t more than 6. Well, if I have something more than 6, I really have 6 plus something, 6 plus t. Most common mistake kids will make with this is because it says a number t more than. More than means I'm actually adding that number at the end. B, 10 less than the product of 7 and f. Same thing, 10 less than, I'm going to subtract 10 at the end. Product means multiply again, 7 and f. So 7 times f. And I'm going to be subtracting 10. Subtraction. Again, another thing we'll see in algebra is instead of having this dot here, or the big cross sign you have for multiplication in the past, we are just going to write this as a 7 and f right next to each other. That means 7 times f, 7, the product of 7 and f. 2/3 of, here's a situation where of just means multiplication. 2/3, and we all love fractions, of times the volume v. Well, there's v. A product, we already talked about product means multiplication, the end result of two numbers being multiplied, of p and 6. Again, there's nothing in between. We are inferring that that means multiplication. 1/3 of the area of A. Again, nasty fractions. I know we all hate fractions, but we're going to have to get used to it. 1/3 of the area A. 1/3 of, another situation where of just means multiply, A. Good. There'll be a little bit more practice for you guys. Okay, you can check answers right away. But first, let's take a look at a real-world example. Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with the web address. Write an algebraic expression to represent the cost of the order. Well, Well, whenever we're writing an algebraic expression, especially when we know what a variable is, we need to identify what the variable is. So I'm going to say k is actually going to represent, do this. K is going to represent the cost of keys, which means I have 250 keys, and each one of those is going to cost me k, whatever that might be. I also have pencils. I'm going to have P represent cost of pencils. So not only did I have this 250k, I had another term. I have another chunk added onto that. Now I do have it 250 times my cost for my keys because there's 250 keychains. I have the 500 pencils and whatever that cost was. 3. Katie estimates that 1/8 of people who ordered beverages also ordered pastries. Let's break this down. 1/8 of the people who ordered beverages. Well, 1/8 is just that nasty fraction. We already said that of means multiply. And the people who ordered beverages, well, we have to assign a variable. Let's say B is number of people who got beverages. Awesome. So now I have 1/8 of times the number of people who got beverages, B. Great. A little bit of practice for you, and you guys are done. I actually joked around. This is the end for you guys, so go ahead and look at your next thing on the website and go ahead and do some practice. Your answer should be there for you.